I'm going to tell you about an exceptional technology for the television and film industry. It's called DIRAC. Whatever part of the broadcast, film or video media you work in, DIRAC has features to help you. It's named after the famous British scientist Paul Dirac, who won the Nobel Prize in Physics in 1933. The BBC Research Department has designed a family of new video compression codecs, suitable for everything from internet streaming to high definition, cinema and beyond, with a performance and efficiency arguably superior to the competition, and with the key advantage that the codecs are open technology, free for anyone to use with no licensing costs. This means exceptional opportunities for manufacturers, development managers and budget controllers who all need to keep those costs down. And DIRAC is available now. Too good to be true? Well, behind me is an uncompressed HD program going through DIRAC codecs. That's a 1.5 gigabits per second signal passing through a DIRAC coder and onto a standard definition chain, because that's the whole point, it's only a standard definition chain. It comes out the other end through a DIRAC decoder, which converts it back to production HD. Then it's further compressed to less than 1/100th of its original size, but when it's unpacked in the viewer's home, you still get an excellent quality HD image. And then, if you want, you can compress it further to really low bit rates, suitable for streaming video to PCs or mobile devices. Phew. Let's look at that in a bit more detail. Go on, you know you want to. DIRAC Pro is a series of codecs designed for high-end production, and it's in the process of becoming an SMPTE standard known as VC2. The DIRAC Pro codec allows the transmission of HD signals along the standard definition infrastructure of existing installations with imperceptible visual loss and low latency. This is really significant for the transition to HD by TV stations and broadcasters around the world. Millions of dollars will be saved if existing facilities can continue to be used for HD. The BBC Television Centre is a case in point. Here, the circuits between the studios, apparatus rooms and routers would have to be upgraded for the BBC's change to high-definition production. Andy Quested is the chief architect behind the transition to HD for the BBC.
The Television Centre was built in 1964 and it's been through many changes, but high definition is something it really needs help with. DIRAC Pro has given us the ability to put high definition through the standard definition infrastructure without making any major changes. We can still monitor it, we can still do everything we need to do with the signal, but actually we're sending a high definition signal through a standard definition building. I mean, the really good news for us is that the potential savings could be in the order of $20 to $30 million when we take our production centres from standard definition up to high definition. I mean, we've already got a really good practical example of how DIRAC Pro is helping us. For the Beijing Olympics, we had to book circuits from the stadium floor back to the switching centres very, very early before we had a high definition service. And we had to book those in standard definition. Now we're able to upconvert those using DIRAC to high definition without loss of quality. And it's been able to get us some really good close-up pictures from the stadium back into the BBC coverage.
And back in the UK, the BBC has an uncompressed fibre network called the Raman network, named after an Indian physicist who was, incidentally, a student of Dirac's. Raman links all the BBC's regional centres around the UK for standard definition television. The DIRAC Pro codec has been tested on the Raman network with HD signals, and the tests show visually lossless results on the pictures and a very low latency of only a few milliseconds. And that's a vital consideration for live interviews between regional studios. So, by using DIRAC Pro codecs, there's a very low cost upgrade path for high definition between the BBC centres. Current estimates put the BBC's savings there at $20 million, and that's likely to grow. For contribution circuits of 50 megabits or more from sources like satellite or outside broadcasts, DIRAC comes into its own. That's because other codecs, such as H.264, are less effective at these bit rates. Cinema is also now going digital. Digital cinema has 4 times more data to process than full HD, and it's another candidate for DIRAC. Film studios are moving to digital cinema or D-cinema distribution and the use of digital intermediates. They're scanning each picture frame at 4K resolution, giving a data rate of a massive 12 gigabits. Because DIRAC codecs perform so well at high bit rates, the film studios are increasingly interested in the potential of DIRAC for part of the post-production process. Peter Wilson is a consultant for digital cinema.
DIRAC's opportunity to optimise for quality rather than compression factor is very much to the Hollywood studios' liking. Hollywood studios have certain standards for quality in their movie post-production, and DIRAC allows them to move this forward. Secondarily, DIRAC has a very flexible feature set which allows them to tune the details into their workflow and makes a very satisfactory tool for them. And it's of course complementary to the system that's been chosen for distribution. And then lastly, of course, archiving. If you can save money on archives, then it's very useful saving. So for example, if you can save 50% of the hardware and the software licensing by doing a visually lossless compression, then that's a very good thing to be able to do.
Now, from one extreme to the other. DIRAC works just as well at low bit rates, and here we're talking about the various distribution applications that require compression by 100 to 1 or more. DIRAC is well suited to the distribution of HD to the home. In the summer of 2008 in the UK, direct-to-home satellite broadcasts were running at about 16 megabits. Broadcasters were hoping to reduce this to about 12 megabits. But DIRAC was already producing similar quality at only 8 megabits per second or less. And DIRAC is also suitable for the lower bit rates used for applications such as video streaming on the web. Furthermore, DIRAC works across all platforms: Windows, Macs and Linux. Which means with the free software that's already available, DIRAC can be used and built into applications for laptop and personal computers and personal media players. From 2009, DIRAC should be a full SMPTE standard known as VC2, complete with recommended operating practice and toolkit. But the key feature of DIRAC is that it's open technology, so there are no patents, royalties or licensing costs to pay, irrespective of whether implementation is in software, hardware or content flow. This means there's no legal process, no complex contracts or lawyers to worry about. Developers can use and experiment with the intellectual property of DIRAC without fear of legal infringement. And business managers don't need elaborate accounting and audit systems tracking content playout. You may wonder why the BBC gives their technology away for free. Well, not only has the BBC more than recovered its development costs, but as a publicly funded organisation, it has a duty to pass on the benefits of its research, both nationally and internationally. In fact, the BBC would like to see the adoption of open technology across the whole industry. So, how do you get DIRAC codecs? Well, for DIRAC Pro, you can simply buy it. A UK company called New Media Technology is now manufacturing a range of boxes containing DIRAC Pro. And apart from the product cost, there are no further charges or licenses for its use. They can be standalone units that are literally plug and play, HD SDI in to SDI out, physically small and with low power demand, or rack-mounted units to add to existing installations. Alternatively, developers can download the specification and DIRAC software and use these to build their own hardware and software applications. And because it's open technology, developers can change or modify it without the burden of licensing restrictions. So, what's the future for DIRAC? Well, the next generation of television is already in development. It's known as Ultra High Definition TV or Super High Vision. Japanese researchers at NHK have invented the system, which has 32 times more resolution than today's HD. That requires an incredible data rate of 24 gigabits per second. BBC researcher Dr. Thomas Davies is working with NHK to reduce the signal data rate to manageable proportions using DIRAC.
The challenge we face is reducing this huge data rate that comes out of super high vision cameras to something that's manageable for studio production and ultimately for transmission to the home. Now, DIRAC's unique wavelet video compression technology is particularly well suited for compressing these very high resolution images efficiently, and that's why NHK believe that DIRAC is potentially the best solution for compressing super high vision video in the future.
So, maybe super high vision will be coming to a TV near you sooner than you think. Dr. Tim Borer is the leader of the DIRAC project at the BBC.
People ask why we developed DIRAC. When we started, we were looking for video compression technology that was suitable for high definition television. Nothing suitable existed. The technologies that did exist were expensive and they had complicated licensing that wasn't suitable for public service broadcaster. The BBC had been working on video compression for many decades, and so it seemed natural to develop our own technology there. The project has more than proved itself. It's developed technology that's been needed by the BBC. It's much more than repaid its development costs, and it looks set to provide big benefits both to the industry and to consumers.
So, to sum up, there are many reasons that make DIRAC the most appropriate compression codec for the broadcaster, film or video media professional today. State-of-the-art technology designed specifically for the industry, an SMPTE standard VC2, simple algorithms mean fewer components, less power, less cost, excellent performance visually, and latency many times better than the competition. The HD signals pass through standard definition infrastructure with no loss visually. It works from the highest to the lowest bit rates. But most important of all, there are no royalties or licenses to pay for the use of DIRAC. It's a completely free, open technology. In fact, wide-scale adoption of DIRAC throughout the industry would lead to new business models and open new opportunities for broadcasters, film studios and viewers alike.